Hello everyone. Hi, I'm Puneet Mathur, the Mad guy. I'm a third year computer engineering undergrad from NSIT University of Delhi. I'm a machine learning enthusiast and I've done a lot of projects in AI and ML. You can check out all of my projects on my GitHub profile www.github.com/pmathur5k10. You can also check out my LinkedIn profile by the name Puneet Mathur. You can tweet to me on my Twitter handle @the Mad guy. All the links have been included in the description below. A shout out to all the great ML people out there. I would like to mention a few great names like Siraj Raval, Andrew Nog, Sendex, and many other ML YouTubers who have helped me to get started in this field. Thank you guys. Thanks a lot. So, what are we going to do today? Basically, today we are going to discuss OpenCV. I have recently done a project in OpenCV which I wish to demonstrate. Well, OpenCV is an old tool, you see. It has been there like for many years, and all the image recognition work was traditionally done in OpenCV. But now the new tool is out. We have neural networks which are very good, very damn good at in image recognition and at various other things too. So why do we use OpenCV at all? Or why shouldn't we just migrate to neural networks for image recognition? Basically, there's a trade-off between generalization and specification. Neural networks are very generic, so you need to feed them with thousands of images to enable them to recognize a few objects in a distinct image. Say, for example, I have an image of a collection of fruits and I need to recognize apple. So I'll have to feed that neural network with thousands of images regarding different types of fruits and different collections of fruits so that when I train that data and test that data, it will be able to recognize apple from a lot of different fruits. But in OpenCV, this is not the case. You just need to be a bit specific. You need to tell it the features that you wish to see that it recognizes in that image, and it will do so. For example, I just need to tell it that, okay, my apple may vary from light red to dark red and is generally round in shape. And it will do the same thing in less time and less computational complexity. So yes, OpenCV is still a rage, and most of the image recognition work is being done in OpenCV. So probably in future years, we'll have a common ground where we'll be using OpenCV as well as neural networks to do some awesome work. So let's get started. So today I've written a script that will recognize various fruits like apple, banana, orange, strawberries in a collection of fruits. I'll just go through the script and tell you each and everything as we move forward. So let us start with installing our dependencies. We have three basic dependencies over here. First of all, the most obvious, OpenCV. OpenCV can be downloaded. I have used Conda to install it. You may use other methods. You can Google it out and do it very easily. So import CV2, which imports OpenCV. The next is NumPy. NumPy is the most important library for all AI, ML, OpenCV, and various other tasks. It is one-stop destination for all the scientific calculation work. Lastly, we have the matplot library, which helps us import the pyplot, which is used for displaying images. So basically, our script is divided into three main parts. First, take the input image. Second, process the image. Third, output the image. So for input the image, I have used imRead method of CV2, which takes in just the file name of the image. I have used a custom defined method for processing the image that we'll talk on later. Lastly, I've used the imWrite method of CV2 to output the image. Basically, you just need to mention the file name with which you wish to save that image and the resultant image that you have obtained via processing. So let's get started and talk about the main processing part. So here is the main processing method, draw apple, which takes in the image of apple as input. So step number 1, we convert the image from blue, green, red model to red, green, blue model. So what is this BGR RGB stuff? See, every image can exist in various types of color model. The very famous color models that we have is BGR, that is blue, green, red, RGB, that is red, green, blue, HSV, that is hue, saturation value, or grayscale. Basically, when we save the image in RGB format, it is stored as a float or signed int of 32 or 24-bit format. The least significant area or the least significant bits are occupied by the blue color, the middle bits will be taken by the green, and the most significant bits will be taken by red. BGR format is just the reverse order of RGB format. As images can be in different formats, so I have just standardized those images in RGB format. The step 2 is standardizing the size of the image. See, the input image can be of various sizes, but the max window size that we have is 700 by 660. So I have defined a scale that is 700 divided by the max size, which is maximum of the image size possible, and then use the resize method of CV2 to resize these images. Step number 3. Every image has some noise, some irregularities, or some random points that we wish to ignore while doing image recognition. So we use the Gaussian blur method of CV2 to do this thing. It returns our image in the variable image underscore blur by taking it 4 input. First the image, second the kernel, and lastly a null value 0. So things have been done so far. We have basically converted our image from BGR to RGB format, resized it, and now removed the irregularities or noise. Next, we convert our image into HSV format. What is this HSV format? HSV stands for hue, saturation, value. Hue is the purity of image. S stands for saturation, which is the whiteness of that image. Lastly, value stands for the lightness or darkness of that image. Basically, HSV format distinguishes luma from chroma. What is luma? Luma is the light intensity of an image. Chroma is the color information of the image. We need to separate these things out so that we can easily recognize image and process them. So next we have created 4 NumPy arrays. Basically, in OpenCV, we need to specify which color we wish to recognize. For example, here I am recognizing the object apple, which varies from light red to dark red. So the hue values corresponding to light red and dark red are somewhere in the range of 0 to 10 and 170 to 180, while the S and V values remain constant in the range of 100 to 256 and 80 to 256 respectively. So once these 2 NumPy arrays have been initialized, we create 2 masks, mask 1 and mask 2, which is formed by using the in-range method of CV2. We concatenate these 2 masks by adding the weighted sums mask 1 plus mask 2 and form a single mask, which will be overlapped on the image. The next few lines of code have been written to identify the contour of the object that we wish to recognize. We used our method find underscore biggest underscore contour to get the contour and the mask. Finally, we use a method overlay mask to overlay that contour onto our image. Then we use the circle underscore contour helper method to demarcate that position of that object by a circle or an ellipse. Finally, we use the show method to display our image. But just before displaying our image, we need to make sure that we convert that image back into BGR format, basically the format that we had initially taken. I'll now discuss the helper functions that I have created over here. So here is the most important helper function, find biggest contour. So how do I find the contour in the image? We first copy the image using copy method. Then we use the find contour method of CV2 to initialize contours and hierarchy. Then using the contour area method of CV2, we find the area or the object with largest contour. And we use the max function which takes in all the contour area sizes and gives out the biggest contour. We return the biggest contour along with the mask. The next helper function that we had used is the overlay mask function, which takes in the masks and the image. It uses the convert color to first convert the mask into RGB format. Then we add the weighted sum of mask and the image to form the composite image, the final image, which is stored as IMG and returned. Next, we have the circle contour method, which helps us to demarcate that object with a contour or a thick circle ellipse, whatever we wish to have. It takes an image and the contour as input. It uses the fit ellipse method of CV2 and draws an ellipse around the contour and returns that image with the ellipse. Lastly, we have the show method, which takes in the image, reconfigures the size of the image, and finally uses the IMShow method of matplot library to display it. So finally, we have written down our script and we run it over here. Python OpenCV underscore detect.py, and here it's done. So here is the object, the image of object apple that I had input, and this is the final output image. You can see over here, this pink area is the mask that we have created, and the green border circle is indicates that that the object has been identified in the image. As you can see, there are some gaps in the mask. This is because of the difference in the values of the numpy array that we had initiated. Next, this is the image of banana that I had input, and here is the output. You can see over here the yellow mask and the green ellipse denoting the recognized object. Here is the image of strawberry that we had input and the output image of strawberry. As you can see over here, very clearly and very distinctly, the strawberry has been recognized, leaving out the leaves. Finally, this was the image of fruits, collection of fruits that we had input. You can see multiple fruits over here, apple, banana, grapes, oranges, so on. And this is the final output image. As you can see over here, this apple has been very clearly recognized in this image. It shows how effective OpenCV is in recognizing images. So yes, OpenCV has its own advantages and it cannot be ignored. With coming of neural networks and AI, things are definitely likely to improve, but we still have a long way to go because of its time complexity and computational complexity. So thanks guys, thanks for watching this video. I'll keep on uploading similar great videos. Thank you. Hasta la vista. Goodbye.